NASA never set out to search the deep ocean for monsters. Its real mission was far more ambitious, preparing for the exploration of alien oceans beyond Earth. But during one expedition to the ocean floor, scientists encountered something completely unexpected. Instruments detected oxygen being produced in total darkness, where no sunlight reaches and no photosynthesis should be possible. The deeper researchers investigated, the more mysterious the ocean became. Before we dive into this incredible discovery, make sure to subscribe to the channel, turn on the notification bell, and join us as we uncover the world's greatest mysteries, from hidden civilizations and ancient secrets to the strangest discoveries beneath our oceans and beyond the stars. Because what scientists uncovered next challenged everything they thought they knew about life on Earth, and possibly life elsewhere in the universe. The deepest frontier on Earth. For decades, exploring the deepest parts of the ocean seemed almost impossible. At the bottom of the Mariana Trench, water pressure is more than 1,000 times greater than at sea level, powerful enough to crush submarines, destroy cameras, and implode sophisticated equipment within moments. That danger became painfully clear in 2014. One of the world's most advanced deep-sea robots, Nereus, disappeared while exploring the Kermadec Trench near New Zealand. After completing several record-breaking dives, the $14 million vehicle suddenly lost contact during its descent. No warning, no distress signal. It simply vanished. Investigators later concluded that the crushing pressure had caused the robot to implode instantly, ending the mission in seconds. The loss forced scientists to rethink deep ocean exploration. Instead of relying on one expensive machine, they began developing smaller, more affordable robots that could work together. And that's where NASA entered the picture. Why NASA was interested. NASA wasn't studying Earth's oceans just for curiosity. The agency wanted to prepare for future missions to icy moons like Europa and Enceladus, where vast oceans are believed to exist beneath thick layers of ice. Those hidden oceans likely share many of the same conditions found in Earth's deepest trenches: extreme pressure, complete darkness, freezing temperatures, and total isolation. To test technology for these future missions, NASA helped develop a new underwater robot called Orpheus. Unlike older deep-sea vehicles, Orpheus was compact, lightweight, and inexpensive enough that losing one wouldn't end an entire mission. Even more impressive, it used autonomous navigation technology inspired by NASA's space exploration systems. Since GPS cannot reach the ocean floor, the robot mapped its surroundings by recognizing rocks, coral formations, and other seafloor landmarks, much like a traveler memorizing a path through a dark forest. Every dive uncovered something even more extraordinary. Miles beneath the waves, where sunlight has never reached, scientists found entire ecosystems flourishing around towering hydrothermal vents, cracks in the seafloor that release mineral-rich water heated to temperatures exceeding 700 degrees Fahrenheit, 370 degrees Celsius. Against all expectations, life wasn't merely surviving there. It was thriving. For decades, scientists believed complex life couldn't exist in such an extreme environment. They were completely wrong. Surrounding these hydrothermal vents, researchers uncovered thriving ecosystems unlike anything ever seen before. Towering tube worms, giant clams, blind shrimp, and countless microorganisms filled the seafloor, yet none of them relied on sunlight to survive. The discovery transformed biology. Until the late 1970s, nearly every scientist believed all life on Earth ultimately depended on the sun. Plants captured sunlight through photosynthesis, animals fed on plants, and every food chain could be traced back to solar energy. Hydrothermal vents shattered that belief. Instead of sunlight, these ecosystems ran on chemosynthesis. Specialized microbes converted chemicals rising from Earth's interior into energy, creating entire food webs powered by geology rather than light. Suddenly, the search for extraterrestrial life looked very different. If life could thrive in complete darkness beneath Earth's oceans, perhaps hidden oceans beneath icy moons like Europa could support life as well. But the deeper scientists explored, the stranger the discoveries became. Near hydrothermal vents in the Caribbean, researchers found blind shrimp living just inches from water hot enough to boil. Rather than eyes, these creatures use heat-sensitive organs on their backs to stay balanced between scalding vent fluids and the freezing ocean around them. When food became scarce, researchers even observed evidence suggesting the shrimp sometimes turned on one another. And that was only one mystery. Elsewhere, scientists encountered methane seeps, cold regions where methane escaped through cracks in the seafloor. These strange habitats supported bizarre communities of life, including worms tunneling through methane-rich sediments, bacteria feeding on toxic chemicals, and mussels surviving through microscopic partners living inside their own bodies. Some of these places looked more like alien worlds than Earth. Then came another astonishing discovery. At the bottom of the Gulf of Mexico, scientists found underwater lakes known as brine pools. Their water was so salty and dense that it formed distinct shorelines beneath the ocean itself. Most marine animals that entered these pools quickly died, yet around their edges, life flourished. Dense colonies of tube worms, mussels, and bacteria survived entirely through chemical energy, creating another ecosystem that existed without sunlight. Each new discovery raised an even bigger question. If life can survive in places once thought completely uninhabitable, then how many other worlds in the universe might also support life? But perhaps the most astonishing discovery wasn't beneath the ocean at all. Deep inside a South African gold mine, nearly 3 kilometers below the surface, scientists found living microbes trapped in isolated water that had remained cut off from the outside world for millions of years. Life, it seemed, could survive almost anywhere. These remarkable microorganisms had never depended on sunlight. They existed completely isolated from Earth's familiar ecosystems, surviving by drawing energy from chemical reactions triggered by naturally occurring radioactive elements within the surrounding rock. In other words, an entire ecosystem was being powered from deep inside the Earth itself. To many researchers, it was the closest example of alien life ever discovered on our own planet. Findings like these completely reshaped NASA's search for life beyond Earth. Suddenly, worlds like Mars, Europa, and Enceladus looked far more promising. Scientists realized that if extraterrestrial life exists, it may not be waiting on the surface. Instead, it could be hidden beneath layers of ice or deep underground, surviving on chemical energy in environments much like those found on Earth. That idea changed the future of space exploration. To prepare astronauts for these extreme environments, NASA even turned to the ocean. Off the coast of Florida, astronauts live inside the Aquarius underwater habitat during missions known as NEMO. There, they rehearse spacewalks, test life support systems, and practice working in isolated environments that closely resemble the challenges of future missions to the Moon and Mars. The ocean became a proving ground for exploring other worlds. Then came a discovery that no one expected. In 2021, scientists placed sealed research chambers nearly 13,000 feet below the Pacific Ocean to measure how deep-sea ecosystems consumed oxygen. The prediction was straightforward. As organisms breathed, oxygen levels inside the chambers should gradually decline. Instead, something astonishing happened. The oxygen levels began to rise. At first, researchers assumed the sensors had failed. That seemed far more believable than oxygen somehow being produced in complete darkness, where no sunlight could support photosynthesis. But every new experiment delivered the same impossible result. Different instruments, different locations, even experiments designed to eliminate microbial activity. The oxygen kept appearing. That left scientists with an unsettling conclusion. Whatever was producing the oxygen might not have been biological at all. Their attention soon shifted toward mysterious metallic rocks scattered across the deep sea floor, ancient formations known as polymetallic nodules. The next discovery challenged one of science's oldest assumptions. Scattered across the deep sea floor are strange metallic rocks called polymetallic nodules. Formed over millions of years, they contain valuable metals such as manganese, nickel, cobalt, and copper. But researchers found something unexpected. Some of these nodules generate tiny natural electrical voltages. This led scientists to an intriguing hypothesis. Could these rocks help produce oxygen through natural electrochemical reactions, even in complete darkness? If confirmed, the implications would be enormous. It would suggest that oxygen isn't always created by living organisms, changing how scientists interpret one of the key signs of life on distant planets. The discovery also raises concerns here on Earth. Many companies hope to mine these nodules for battery materials, but researchers warn they may support fragile deep-sea ecosystems that are only beginning to be understood. The deeper scientists explore, the stranger our own planet becomes. Boiling hydrothermal vents filled with life, underground microbes surviving without sunlight, and mysterious mineral formations that may be capable of producing oxygen in the darkest parts of the ocean. Earth's deep sea has become more than an unexplored frontier. It may be the closest natural laboratory we have for understanding alien worlds, perhaps beneath the frozen ice of Europa, beneath the surface of Mars, or inside oceans orbiting distant stars. Similar ecosystems already exist, waiting to be discovered. And that's why NASA continues exploring the abyss, because every new expedition brings us one step closer to answering humanity's greatest question. But perhaps the most remarkable lesson isn't what scientists have already discovered. It's how much they still don't know. For centuries, humanity believed the oceans were little more than empty water stretching across the surface of our planet. Maps showed coastlines in incredible detail, yet everything beneath a few hundred meters remained almost completely invisible. Even today, despite satellites, artificial intelligence, and advanced robotics, researchers estimate that only a small fraction of the ocean floor has been explored in high resolution. In many ways, we know the surface of Mars better than the deepest regions of our own world. Every expedition into the abyss reminds scientists that the deep ocean follows its own rules. Temperatures hover just above freezing. Sunlight never penetrates the darkness. Pressure reaches levels capable of crushing steel. Yet life continues to adapt in extraordinary ways. Creatures living thousands of meters below the surface have evolved transparent bodies, glowing organs, expandable jaws, and biological systems unlike anything found in shallow seas. Some fish create their own light through bioluminescence. Others survive months between meals, waiting patiently in darkness for the slightest sign of movement. Nothing about this environment seems ordinary. And that's exactly why space agencies continue paying attention. If life can evolve under these extreme conditions, then perhaps the universe is far less empty than we once imagined. For decades, scientists searched for planets that looked like Earth, warm worlds with blue skies, liquid water, and sunlight. But discoveries beneath our own oceans have expanded that search dramatically. Now researchers ask a different question. What if life doesn't require sunlight at all? What if chemical energy alone is enough? That possibility has transformed planetary science. Europa, one of Jupiter's largest moons, hides a global ocean beneath an icy shell that may be several miles thick. Evidence collected by spacecraft suggests that this hidden ocean could contain more liquid water than all of Earth's oceans combined. Enceladus, a moon orbiting Saturn, is even more intriguing. Are we alone in the universe, or have we simply not looked deep enough? If you enjoyed this journey into one of science's greatest mysteries, subscribe to the channel, turn on notifications, and let us know in the comments which mystery you'd like us to uncover next.